Hello, 11th graders. So we are moving on in our geometry unit. Last unit, we talked about a little bit of coordinate geometry, about finding distance and midpoint, about finding perpendicular bisectors, the relationship between the intersections of lines. And today we're moving into a little bit of trigonometry. So trigonometry is really kind of born in the idea of right triangles. It expands and further goes out into the world to go do a bunch of cool different things. But we really start talking about trigonometry when we start talking about right triangles. And really the bare essentials of what trigonometry is and what these trig values are is the relationship between side lengths of right triangles. So what that means, if I were to show you on our notes, I'm going to draw a right triangle. And I'm going to pick one angle right here. I'm going to label it theta. Theta tends to be the go-to variable a lot of times for trig values. And when I'm talking about theta, I'm only talking about that angle. And with that angle, I have three different side lengths, and they all have a specific relationship back to that angle. There's always the hypotenuse. So if I were to just zoom in here, we always have the hypotenuse. That's pretty standard. That doesn't matter where your angle is. It's always just opposite of your 90-degree angle. So your hypotenuse is right there. Then we have opposite side lengths. Opposite side lengths, think about your angle as like a spotlight opening up to that opposite side. So here is the opposite side length of that angle theta. And then our last one, and this is how I will label it when I'm trying to figure out relationships within right triangles. I'll first label the hypotenuse, then I'll label the opposite side, and then whatever side is left over is the adjacent side. Adjacent means that it is next to the angle. Now, be really careful. There are a lot of students who will then start labeling the hypotenuse as the adjacent side, and that is not true, right? The hypotenuse is always opposite of the 90-degree angle. Whichever one is left over in terms of the next to of that angle is going to be your adjacent. So these are all side lengths, and they all have a relationship back to that angle in the right triangle. And so now when we start now we're going to start talking about the relationship of those side lengths to each other and how we label them. So we have sine of that angle. Realize that there are parentheses here. There's sin. Technically, sine is spelled S-I-N-E, but the shorthand for it is sin, sine of, and then we've got this little parentheses piece. This does not mean multiplication. This means that your angle is inside of sine, right? So like what we talked about in our graphing, we're not multiplying it here. Sine is the relationship of your opposite side length over your hypotenuse. We have a different one called cosine of theta. Cosine is the relationship of your adjacent side length over your hypotenuse. And our last one is tangent of theta. Tangent of theta is your opposite side length over your adjacent side length. And that's what it all boils down to, is sine, cosine, and tangent are all just the relationships of those side lengths put into fractions together. Sine as opposite over hypotenuse, cosine as adjacent over hypotenuse. So sine as opposite over hypotenuse, cosine as adjacent over hypotenuse, and then tangent as opposite over adjacent. How we remember those relationships is the phrase SOHCAHTOA. It is a go-to phrase. You'll hear people say it all the time in reference to right triangle trigonometry. SOHCAHTOA. TOA. If you have a hard time remembering these relationships of side lengths, definitely feel free to write SOHCAHTOA at the top of every problem that you have to deal with right triangle trigonometry. If you write it down, you can just look through it. It's like a recipe. Okay, I have the hypotenuse and I have the adjacent side. So where are A and H next to each other? Oh, with the C, which is cosine, right? So it's kind of like a step-by-step foolproof way to make sure that you're using your right triangle trigonometry appropriately. These are all, we use these guys for the most part to solve for side lengths. We also use something else that's called your inverse trig relationships. We'll do them like this. Your inverse, not cosine. We'll do sine first. Your inverse trig relationships look something like this, where they have a -1 to the power there. They are not like 1 over sine. That is not what it means here, which is very confusing because typically when we see a -1 in the reciprocal, that means that, or in the exponent, that normally means that we are reciprocaling it, or flipping the fraction, and that is not this case. In this case, to the -1 power means that it's the inverse, which is different than reciprocal. Okay, so this is the inverse of sine, and the inverse of any function takes your input and your output and switches them, right? So if we're talking about sine, where typically our input was before an angle, and then our output was the relationship between side lengths. Now, when we're talking about the inverse of sine, we're talking about their input being the side lengths. So that's opposite over hypotenuse, and then it gives you the angle. Same with cosine. And it gives you the angle. Okay, so whereas our original trig values were giving us side lengths, for helping us solve for side lengths, if you're ever asked to solve for an angle, this is what you do instead. If you go to your calculator, if you have a TI Inspire, it's next to the 7. You press the trig value there, and you'll see your sine, cosine, tangent, along with cosecant, secant, and cotangent, which we'll talk about maybe later. I'm not even sure if you guys actually end up talking about those guys in this class. But you'll also see below it to the -1 power, that's going to be your inverse trig values. You'll see sine -1, cosine -1, tangent -1, and that's how we solve for our angles. So just a kind of helpful hint for us. This is to help us solve for angles. All right, I think that's all we need to know about right triangle trigonometry in order to get started on our notes. So it says to use your calculator to find the following trigonometric ratios correct to 3 decimal places. This is just getting you familiar with your calculator, also seeing the relationships between these trig values. So 30, 45, 60, 90. Okay. So for we're doing sine of 30, sine of 45, sine of 60, and then sine of 90. Just going to your calculator, you press that little trig button. We're going to go to sine, and I'm going to plug in 30. Make sure that your calculator is in degree mode. We will never be doing radians in this class again. I think I've mentioned this many times in this video format, but I think some of you maybe aren't watching it. I don't know, but I'm seeing still a lot of people using radians. I don't know how you learned those, but you're not doing them in this class. So those are all of your sine values for 30, 45, 60, 90. These are very common angle measures that we would plug in for your trig values. We're going to do it again for cosine. So we get cosine of 30 is 0.866. 45 is 0.707. Cosine of 60 is 0.5, and cosine of 90 is 0. And then tangent. Okay, so we get 0.577, 1.73. I think it said 3 significant figures. I'm going to keep doing 3 significant figures. And if I remember correctly, tangent of 90 is undefined. Explain why for any angle theta where the sine. Explain why for any angle that sine and cosine are both less than 1. How is this different from tangent? So how we know that this will always be less than 1 is because we're looking at the relationship of side lengths of right triangles. Going back up to the side lengths of the right triangles, sine and cosine always have hypotenuse in the denominator. Hypotenuse is defined as the side length that's across from 90 degrees. It's also always defined in a right triangle as the largest side. There will be no other side in this right triangle. The opposite and the adjacent side length will never, ever, ever be larger than the hypotenuse. So taking that idea and that concept and turning it into an arithmetic idea, if the hypotenuse, the largest number, is always on the bottom, always on the denominator, your numbers up top are always going to be smaller than your hypotenuse, no matter what right triangle you're talking about. Otherwise, it's not a right triangle. Otherwise, maybe you've set up your relationships wrong, but it will always be the larger number on bottom and a smaller number up top, which will always be a number which results in less than 1. Versus tangent is opposite and adjacent, and those could be any relationships, right? They could always be opposite and adjacent, doesn't matter. One could be like super, super long and one could be super short, or they could be about the same. They could be exactly the same if we're talking about a 45-45, right? It would be an isosceles, right, triangle. So we've got a full range of possibilities for your tangent values because we're not comparing it back to the hypotenuse. With sine and cosine, since we're always comparing it back to the hypotenuse, it will always be less than 1. So go ahead and take a second right now to write down what I said. If you need to reverse and think about it a little bit more, or if you need to ask me questions about how to write it down, if I write it down, it's going to take forever because writing with a stylus is a pain in the butt.